Okay, crew, these are our 2-5 notes, which are our last notes for our second unit in pre-cal, our first unit in trig, and we're going to look at 3 of our inverse trigonometric functions and how to use those to solve triangle problems. So our primary focus is going to be solving problems using trig that involve triangles. Let's start with what we already know. We know that if we say that the sine of theta equals 2/3, that the sine is our function, that theta is our input, and our output is 2/3. So the input of our sine is theta, which is the measure of an angle. 2/3 is our output. It is a ratio of either the sides of a right triangle. So in this case, our sine would be the opposite side to our angle divided by the hypotenuse of our right triangle. Or it is a ratio of the coordinate of a point on the terminal side of an angle and the distance from the origin to the point, which we call the radius. So for sine, that would be the v, the vertical component, or the y coordinate, divided by r. Now, what's new to know is that there are inverse trigonometric functions. And when we use a superscript of -1 on a function name, in this case the sine, that indicates that we have an inverse function. So this is the symbol for the inverse function of the sine of theta. In this case, the x, the input of the inverse sine, is our ratio, and the output would be the measure of an angle. So if we say that the inverse sine of 2/3 equals theta, 2/3 is our input and theta is our output. Remember that with an inverse function, the input and output switch places. Right? So theta is the angle whose sine is 2/3. Or in other words, if the inverse sine of 2/3 equals theta, then we know that the sine of theta equals 2/3, right? Notice, input ratio, output angle, output ratio, right? They have switched places. The other thing that's new to know is that we can find the inverse of the sine, cosine, and tangent with buttons on our calculator. So if you'll look on your calculator, at the button that says sine, above it, it says sine -1. So if you do second sine, you're going to access the inverse sine, right? Likewise with cosine and with tangent. So go to your calculator, right, and put in second sine to access your inverse sine of 0.4. And what you're going to get from that is 23.578. The input is a ratio, the output is an angle, so that's in degrees. And what that tells us is that the sine of 23.578 degrees will equal 0.4. If we put in, there should be an S here, right? If we put in the inverse cosine of 0.1579, the calculator is going to give us 80.915. That's an angle, so it's measured in degrees, and what we know is that the cosine of our 80.915 degrees will give us the ratio that is expressed, right, as the decimal 0.1579. Put in inverse tangent of 12. The calculator is going to give you 83.236, which tells us that the tangent of 83.236 degrees will equal 12, right, which is the ratio of 12 to 1. Now it's important to mention a few things. One of those is that when you use inverse sine, inverse tangent, inverse cosine, these functions, these inverse functions, will return an angle that is always within a limited range. The inverse sine will always give you an angle that's between -90 and 90, as will the inverse cosine, inverse tangent. The inverse cosine will always give you an angle between 0 and 180. We'll talk more about that later in our study of trig in a later unit. The other thing to notice is that when we have that superscript of -1 on the sine, that's a -1 on the function name. That indicates we are taking the inverse of that function, right? And what it gives you is the angle whose sine is the input of that inverse function. If we were to put -1 on all of what the inverse sine is, that inverse sine is a number. When we put a negative superscript on a number, it means the reciprocal of the sine. So 1 over sine, which we know is the cosecant. So -1 on a function name means inverse. -1 on a number means take the reciprocal. All right, let's go to where we're wanting to be, and that's in solving triangle problems. Here are your guidelines. For each of these problems, you're going to draw a picture. When you draw that picture, you should identify a right triangle. Be looking for a right triangle. You need to label that triangle with what you know and with what you need to find, right? Give what you need to find a variable. You need to identify a trig function which will involve an acute angle of your right triangle and 2 of the sides, right? An opposite side, an adjacent side, and possibly the hypotenuse, so 2 of those 3. Then you're going to solve that trigonometric equation using the things we've learned. Okay, so if you follow those guidelines, these problems are not difficult. I think you're going to enjoy them. Here's our first example. Suppose you have the job of measuring the height of the local water tower. Climbing makes you dizzy, so you decide to do the whole job at ground level. Right, so here we go. We're going to draw a picture. This is the ground, right? So you've got, that's grass there, okay? You've got the ground. Atop of that ground, you have a water tower. Okay, here's my water tower. Right, that has water in it, H2O. Okay, your job is to measure the height of the tower. Right, so we need to measure what the height of this tower is from here to here. Climbing makes you dizzy, so you decide to do the whole job at ground level. And you find that from a point 47.3 meters from the base of the tower, you must look up at an angle of 53 degrees. Okay, so that means you must be somewhere over here. And what we know about you is your distance from the base of that tower is 47.3 meters. And you are looking up, so I know your eyes aren't on the ground, but we're going to go with it. You are looking up to the top of that tower, right? This is where our triangle is going to be, at an angle of 53 degrees. So this angle is 53 degrees. Okay? An angle of elevation always goes from the horizontal, rotating up, right? Elevating. This is our right angle. I'm going to take this line out here. This is the base of our triangle. And our job is to measure how high that tower is. So let's call that H. So when I solve this problem, I'm going to come in here and I'm going to say let H equal the height of the tower. What do I know about my tower? I know an angle, right? This is 53 degrees. This is my theta, that's my angle, and I know this side, which is the adjacent side to that angle. So, right, I want to write a trig function. Which trig function uses the adjacent side and this side, which is the opposite side? Well, that would be tangent. So my equation would be that the tangent of my angle, 53 degrees, will equal its opposite side, which is the unknown height, divided by the adjacent side, which is 47.3. My job is to solve this equation for H. So I'm going to come in here and I'm going to multiply both sides by 47.3. That will divide out the 47.3s, and I am left with h equaling 47.3 times the tangent of 53. I can evaluate that with the help of my calculator, and I end up with, right, this number, oh, I have that. So I end up with 62.769. That number has meaning. That's the height of my tower. If the base, right, the distance was in meters, then this must also be in meters. And we have answered the question. Okay, let's do another example. So example 2. A ship is passing through the Strait of Gibraltar. So a strait is a passage of water between two pieces of land. So somehow I've got this land, we're going to call this Gibraltar, right? So that's Gibraltar. And this is the water. And I've got a ship that is passing through. So let's say, this is my artistic abilities, that S represents my ship, and that ship is passing on a path, right, through that water. This says at its closest point of approach. So the closest my ship is going to get to Gibraltar, right, this is my ship at its closest point, is going to be when its distance is perpendicular to its path. So this is going to be perpendicular. Gibraltar radar determines that the ship is 2,400 meters away. So I know that this distance here is 2,400 meters. And that's my perpendicular distance. Later, the radar determines that the ship is 2,650 meters away. So let's say that later is here. So here's my ship later. And at that point, the distance from Gibraltar is 2,650 meters away. So that's this diagonal distance. Okay, well, look at what we see. Here we've got a right triangle. And I know two sides. I know the hypotenuse, and I know one of the other sides, one of the legs. Question is, by what angle, theta, did the ship's bearing from Gibraltar change? Well, from Gibraltar, right, the angle that we're talking about would be this. So that's my theta that I'm trying to solve. So what do I know? I know that, right, I have my hypotenuse. For this angle, I have its adjacent side. So we're going to write a trig function. Which trig function uses the adjacent and the adjacent and the hypotenuse? Well, that would be cosine. So I can write that the cosine of my unknown angle theta will equal the adjacent side to that angle, which is 2,400, divided by the hypotenuse, which is 2,650. By the way, these are both measured in meters, and like you do in science, you can divide out those units. So I have my cosine is equal to a pure number. I could take that and I could reduce it. It's not absolutely necessary, but if I reduce that, right, it will reduce down to 48 over 53. Okay, the key here is that I want to evaluate theta, which means I need to get rid of cosine. What can get rid of a function is its inverse. So I'm going to come in here and I'm going to take the inverse cosine of both sides of this equation. We can do anything we want to an equation as long as we do it to both sides. Right? Because these are inverses, the inverse cosine of a cosine will give us back the original input, which is theta, and I have theta is equal to the inverse cosine of 48 over 53. Well, good news, you have a button on your calculator for inverse cosine. You evaluate that, and you get that theta is equal to 25.088. That is an angle. It is measured in degrees. So that's my A. Right? B says, how far did the ship travel between the two observations? So that's asking me to find this distance right here. Well, how can I find that? We'll squeeze B in here. Well, these are the legs of a right triangle. When all I have is the legs of a right triangle, I can use Pythagorean's theorem. So I can set that up and I can say t squared plus 2400 squared must equal 2650 squared, which means that t squared must equal whatever 2650 squared is minus what 2400 squared is. I evaluate that, and again, you've got a wonderful calculator that can do that for you. You get t squared is equal to 1,262,500. I want to solve for t, so I take the square root, right? Strictly, this would be plus or minus, but when we're talking about a distance, it's got to be positive, and we get t is about 1123.610 meters, and we have found our answer for A, and we found our answer for B. All right. One more example. Okay. This is our California interstate problem. And this tells us that Interstate 5 in California, by the way, I've been on that highway many, many times, grew up in California, enters the San Joaquin Valley through a mountain pass called the Grapevine. The road descends from an elevation of 3,000 feet above sea level to 500 feet above sea level in a slant distance of 6 miles. All right, so this is what's going on. We're going to take this and we're going to call this sea level. So my highway goes from an elevation of 3,000 feet above that sea level. So it goes from here, and we'll say that that's 3,000 feet, and then drops to an elevation of 500 feet. So we'll say that 500 feet is here. And the slant distance from where it starts to where it ends is 6 miles. Well, I can get a right triangle out of this if I break this up. So if this distance from here to here is 500, then this distance is 500, which would make my distance from here to here actually 2,500. And so that's 2,500 feet. Now I have a problem. My problem is that I have units in miles, I have units in feet, and I really need them both to be the same. So if I take my 6 miles and I multiply that by, what is it, 5,280 feet per mile, right, I end up with 31,680 feet, right, is my equivalent for 6 miles. All right, we are looking at a right triangle. We are trying to find the angle the roadway makes with the horizontal. So this slanted line is my roadway, horizontal is here. I'm looking for this angle. Let's call that angle theta. So from the perspective of that angle, I've got this side, this is its opposite side, right? And I have this side, this is my hypotenuse. So I want to write a trig function that uses the opposite with the hypotenuse. Well, that would be sine. So I would have that the sine of theta equals the side opposite theta, which is 2,500 feet, divided by the hypotenuse, which is 31,680 feet. Again, my feet divide out, which is good because my sine is just a pure number. I want to solve for theta, so I'm going to take the inverse sine of both sides. Right. So my output is just theta, and I get theta is the inverse sine of 2,500 divided by 31,680. Now this time I didn't reduce this fraction, but my goal really is just to end up with theta. My calculator can handle that number, and when I put that in, I get 4.526 degrees. So this road is increasing on average, right, at a 4.526 degree angle. All right, so here we go. What do? We read the problem. Right, we draw a picture. Look for a right triangle, label that triangle, identify an angle, opposite side, adjacent side, hypotenuse, write an appropriate trig function using those right triangle ratios, solve that equation, and you got it done. You can do this. Great job.